My name is Ole Tran. My background is from iOS coding back in the day, and it's started doing that in 1998. And it's kind of amusing that the pendulum is kind of back. We're doing, using many of the same techniques that we did in iOS, control plane code, run to completion and do packets in bursts and lightweight threads and so on. Then I went off coding for a while and did quite a lot of ITF work, and now I'm wanting to do more running code in the ITF, and I found VPP, and VPP is an amazingly fun environment to work in, depending on where you come from. Certainly, if you come from coding iOS XR or iOS that I have, or even trying to do a network protocol in Linux, which is a pain in the arse. So VPP is very, very nice. It's very easy to do anything you want to do with packets without anything hampering you. And I think when you get to know those data structures, you will find that they are very, very suitable for their use. And that consequence of using indexes instead of pointers is quite wide-reaching, which you'll find out. And in iOS we always use pointers, and there's a lot of work making sure those were right and cleaning up stuff when you change data structures and stuff. So please, bear with me. So that's my background. iOS and its way of interacting with the world was the CLI. And we tried many times to provide, APIs to, allow iOS to be programmable. That turned out to be very, very hard, because all the developers were used to using the CLI, all the customers were using the CLI. Automation of testing was done using, screen scraping CLI output and sending CLI commands. There's some benefits to that. The CLI is quite well thought out and it was quite stable. Of course, if you wanted to change the CLI output, it was a catastrophe because all these TCL scripts would fail. Which is why I'm quite ambivalent to the VPP CLI, because please don't go down the same route, right? Just do things in the CLI, develop everything, do all your development work with the CLI, make customers use the CLI, then we're not able to make this programmable, right? So that's why we call it the debug CLI. But I'm a bit ambivalent because, at some stage you could look at this as, well, I'm just writing an application with a configuration file that is pretty much static, and we certainly have use cases for that where we don't need a control plane, and where you would just take those CLI commands, wrap it up in a container and dump it somewhere, and run it just like you ran any other Unix daemon, right? Bind or Apache or whatever. So I think the CLI definitely has a place. It's just that it's we have to make sure that we can do everything through the API and that we make this programmable, because it's an easy easy trap to fall into, and so we had one committer that made the CLI do auto-completion and allow editing and history and stuff, and I was kind of like, no, let's make the CLI awkward to use. Don't make it easy to use and comfortable to be in, because that's just going to hinder people doing the right thing. So we'll see. I mean, I tend to be very opinionated about things I don't know anything about, and in this case, I'm sort of like, it depends. I mean, I don't, there's space for both here, but we just have to ensure that we can do everything through the API. So this is kind of where VPP sits. Is there a pointer on this, perhaps? Oh yes, it is. So the CLI sits within the VPP process, supports configuration files, and the CLI, as you'll see later, is it is a very simple thing to add a new CLI, and it calls an action handler, and that's the same action handler that the API calls. So there's a few conventions there that, as long as we keep those, maintaining both the CLI and the API is going to be quite simple. The API is implemented, as I think mentioned before, across a unidirectional shared memory interface, lockless. There is a socket version as well, but pretty much everything uses the shared memory interface. On top of that, it's the VPP API tester, which is the one used through that VPP's control. Is that the script that Ed wrote on top of this to send commands? I think he showed it yesterday, whatever it is. Then there's the Python binding that I wrote. Happy to have someone who actually knows Python who would help me out cleaning that up, because it's purely written from. I wanted to be the ability to write unit tests in Python, which is why I wrote it, but it certainly isn't production code. Then there's the Java binding that ODL Honeycomb uses, and we have also a proprietary module called Orca, which is the middleware between VPP and confd, another Cisco proprietary product. I think it's actually an open version of that, but it's or part of it is open source. So how you want to extend this, or where do you want to build your apps on top of this? You could certainly build them up here, right? Or you could build them on top of Python if you wanted to. You could build them directly on Honeycomb, I suppose, or you could build them, directly as new apps on the shared memory interface. I'll talk a little bit more about futures as we get into how these APIs are defined. Especially the language that's used to define APIs, which is very. It's not very explicit in its RPC definitions, to say it that way. Please just interrupt me with questions, and I can relay the questions from here, so we don't have to pass that microphone around all the time either. So the API code is split across quite a big part of the directory infrastructure. The language bindings are up here in VPP-API. The tool that parses the API definitions and generates C header files and C structures is a Lexiac thing that Dave Barak wrote decades ago. Is sitting here in VPP API gen. I modify that slightly to output a Python-friendly data structures, which is used for automatically generating language bindings for Java and Python. Then we have the VPP API test, which is a C client in VAT. And then there's the actual implementation of the shared memory API here in VLib-API, with socket being the streaming API using TCP sockets, and VLib memory being the shared memory one. VLib API has all the shared code between client and server. And here in VPP API is the server side of the API. All the handlers are in API.c, so that's kind of a massive file. And all the definitions are in VPP.API. At some points it used to be called VPE, then we renamed it to VPP, but there's some remains of that here and there. I see I might rename that one at some point. Plugins will have their own API files, so they are done independently of this one, and it's probably a cleaner way of adding new functions. So one way of VLib CLI command, I think, is the macro to add a new command. So if you want to look at what command handlers and what commands are in there, you can just grep through these. Let's see if that one is there. Yes. Oh, yeah. SR content command is the sample.c. Let's see where that one is. Okay. So here's just the macro to add the sample max swap command. Just say, define which path you want to attach it to, help string, and which function to call, which goes through, pretty much all this magic that Pierre showed with, unformatting the input string you get. And then somewhere here it will call this function sample max swap enable disable, which is that common action handler between the API and the CLI. And you essentially do the same thing with adding show commands or APIs. So this runs in the main thread, and it's Damien said either there will be a barrier syncs blocking all other worker threads while you run this code, or it has to be thread safe. And there is a in the macro definition you can add a isMP safe parameter as well, I believe. Isn't that true, Damien? Sorry? Yeah, good, you're paying attention. It's true. Yeah, just raise your time. Yes, again, my perspective from this is I came into this about a year ago. I wanted to implement something as a user. What's the easiest way for me to write a new tunnel concentrator into VPP? And I think the general recommendation is, if you don't want to understand everything and read all the code, just follow the skeletons which are here, and all the templates. Just follow the existing code structure, and then you can start as you gain a wider understanding. You can you can start doing more experimentative things. So by the way, in build root, I don't know if anyone mentioned that there's a set of Emacs skeletons for various code patterns that you can then copy and expand into. If you're not using Emacs, then well, use Emacs. Well, that's a dangerous discussion to go into, isn't it? So if we get time at the end, I mean, we can certainly try, try adding a new CLI command and see what, how that would look like, and how we can do that, and add new APIs as well. Let me just see on. So the command action handler here. So I'm going to merge these two sessions a bit. So we're going to look a bit on the action code as well. But when it enables it, it calls this VNet hardware interface RX redirect to node with itself. So that actually intercepts packets quite high up in the graph and says, send all these packets to me. I don't know if Pierre mentioned that in the last session, but you have to have some sort of agreement with your parent node. If you want to add yourself to the parent node, you have to have some way of telling the parent node that you want certain packets. And one way of doing it is through this VNet hardware interface RX redirect to node API. But of course, that that's not general, right? That just takes all the packets from that node, send them to me. And it really depends on the parent node what kind of API it supports for dynamically adding, other children. And yeah, so that's the CLI command here. If you want to add configuration parameters at boot time, that's sort of a similar macro. What was that called again? Yeah, vlib config function, which then is a similar registration macro where you can add new command line options to VPP. For example, where you have you want to add something like Unix interactive or API trace on, or your own little bit here that you want for on startup, you can register a function with vlib config function, and you'll get more. Yes, so that is the startup.conf. So that's how you would add new stuff in there. Yeah. So later, add a show command to maxswap on the CLI, and we'll see how that goes. Okay, so for the API, let's have a look at the VPP.API file. So this looks almost like C, right? But not quite. And this is parsed through the API gen tool to generate C structs, Python. Should I move it higher up on the screen, or can you? And it has this just defines the messages, right? And these are then parsed and made into C structures. The API is network byte order, by the way. Wouldn't it be nice if all CPUs were big endian? Oh. By now, yeah. Has all the Intel guys have left. Yeah, we're stuck with it's little endian. It's just such a pain. So in iOS, we actually managed to get iOS to run on x86, but using special compiler that would do the endian stuff for us. ARM that's also little. It's by endian. Little endian is the preferred. So should we change instead then? Should we go in the IETF and said now network byte order by declaration is changed? Yeah, that's not going to happen. So we support 3 types of API calls. It's a request reply. So the client calls show version, and it gets a show version reply message back. Note that these might be strings. Who knows? They're U8s. It's a qualified guess that they might be strings, but there are some quite this definition is not explicit, right? The only from the perspective of generating the Python binding, you just have to assume that the convention is followed, and you have to follow this convention that the client call is called something, and the reply is called something _ reply. If you don't follow that convention, the language binding will not be generated correctly. So yes, so in this case, the caller of the API would have to know that program is actually a character string, and so the great thing about open sourcing this is that now we can have this discussion out in the open, and we could have we certainly have thought about other languages like protobufs or Thrift or Captain Proto, or something that is much more explicit in how this RPC mechanism works, right? But as long as, at least for now, when you add a new API call, please follow this convention. The other one is well, perhaps yes. The other one is dump and details. So please, the client calls IP address dump, with some parameters. The context is just so you can map the reply back to the request, which interface you want this to be on, and if you want v6 or not. Assumption is that if you don't want that, you get v4. And then you get the response with a set of IP address details messages. And you don't know when that set ends. You just get a set of messages, and in theory you can get those could keep arriving forever. So there's an actual ping message that you then send that is a request reply message. So it's guaranteed to be serialized. So you get when you get the ping reply back, you know that you got the last details message. A bit clunky indeed. The other interesting detail with the dump details API is that you don't necessarily only get one message type, you can get multiple. Let's see. So for software interface details, you get the software interface details message reply, and you get the software interface set flags reply as well. And again, in the API definition, there's no explicit statement anywhere that which ones you get. So you actually have, when you implement something over the API, have a look at the handler code to make sure that you understand what's going on. I mean, it's a very tightly coupled API, right? So
you can never expect to get a specific response because you can get the whole set of.
Right.
They probably derive from your request.
Yes. Yeah. So, or you have to go and look in the actual handler to see what possible messages you will get back. I mean, the common one is that obviously that you get only one message type. This software interface type is somewhat special. Okay, and the last type we have is this pub sub type, where you send a want interface events, so you register for those events, and you will get those messages whenever these events happen. So you send a want interface event, you get an events reply back immediately, then you enable that, and then you will get whatever messages is implied by an interface event.
Without flow control.
Yes.
And that has never bitten you.
Yeah. So you have to, there's certainly implemented specifically for this custom case, and you can argue, do you want to build, have a layer in between here, so you would perhaps hide yourself from all of this and build things on top of the Java binding, for example, where many of these things are hidden away. Or do you want in parallel to provide something like a thrift API or something else? It depends. So this is very very high performance. We can do several 100,000 messages a second. Very useful to load large tables, for example. There's also ways of calling the CLI directly here, whatever the CLI command was called, which we well, let me just say. Let's make run that. Yeah, so exec show version calls the CLI directly. Show version calls it through the through the API call. So that sends the CLI string across the API. This calls the actual function.
Question.
Yes.
Is it possible to send a command? Is it possible to send a command or request that's not recognized by the VPP? Now, is there any kind of negotiation about what messages are supported?
Yes. So there is a very so the API generator creates a CRC checksum, a signature of the API, and that signature is passed when you connect. The client connects to the server. So if the checksum doesn't match, it refuses to connect.
So there's a strong dependency, but that they actually have exactly the same version.
Exactly the same
version.
Okay,
so the client part can't be a separate version.
No.
Different. It has to be very tightly coupled to the VPP.
Yeah.
Okay. Then you don't really know. You don't have this problem with different versions, different parts of this communication implementing different messages.
Right.
Yeah. Okay.
Right. You could certainly imagine, at least if you build something on top, that you would make it, evolvable and backwards compatible, and you could extend the API without that limitation, I think. But in this, in the actual, shared memory binary API, it's how it's done. Feel free to contribute if you want it to work differently.
No, I think if this strong dependency, if that works for the use cases, it's probably preferable, because this to version handle these two sides separately, and then you have to negotiate. What can you do?
Yeah.
Do you support this message? Oh no. Okay. Well, that's just problematic.
Yeah.
So the simple solution is avoid it.
Yeah.
As long as that's okay.
And there is a philosophy in VPP, I think, that in Cisco we implemented high availability and ISSU, and ISSU is a fucking pain in the arse to support. I mean, it's a terribly bad idea, and it's a lot easier to just restart the process then. I mean, it takes it doesn't. Okay, so this is just an empty VPP, but boom, I'm up, right? It's not like a router that needs 15 minutes to start. It takes seconds. And instead of trying to support service upgrades in flight and deal with incompatible APIs and stuff, it's such a space for bugs. I mean, it's so hard to make work, and it makes testing also very, very painful. So
now this is everything Ericsson has been doing for like the last 50 years. Take that away.
I know.
The purpose of existing.
Well, yes, we're in the shifted industry, and who knows who's going to exist tomorrow. I mean,
yeah, but I mean, you're just shifting the problem one layer up, right? Because there will still be a management layer orchestration. There will still be a management layer, orchestration layer, something sitting higher up in the hierarchy that configures the VPP node directly or indirectly. And that is not hard coupled. So the compatibility aspects problem remains. It's just shifted one layer up. So I guess my next question, maybe you will come to that, is assume that Honeycomb will be the management agent. How do we translate all these API definitions into management models of VPP node Honeycomb?
Right.
In some language that does then include compatibility mechanisms and blah blah blah, extensibility. Are you coming to that, or
no?
No. Okay. Are we going to cover it anyway these days, or?
I think there is someone going to talk in more detail about Honeycomb, isn't there, Pierre, or not?
There was on the first day.
I mean, one answer to that is standardized Yang models, right? But of course, as soon as you add your own knob, which you have to maintain, then you end up with some proprietary extensions that you have to manage, and it's difficult.
But that's the strategy, right? It's Yang models and okay,
yeah,
good.
Well, back to this is why I'm kind of ambivalent about the CLI, right? Because evolving the CLI, is in some phase a lot easier than not, and then doing the API and dealing with all these backwards compatible things, and it's it counters on a debate we often have in the ITF these days about what's the consequences of open source on standardization, and to some extent we've seen that open source has led to monocultures where you don't need standardization so much, and if you control both ends of the pipe, then who cares about if you do API changes, boom, do them everywhere, since you control it, sorry. I have my ITF t-shirt on still, so I don't necessarily think we should go all the way there, but that's certainly one option. One thing the API also supports is API tracing, which is quite a neat mechanism, especially in a running deployment where you get some bug report and you want to see what was actually going on. So I think the default trace size is 262 messages it pairs. So I can do API trace save foo for API trace bar then. No, what? API trace, say, do I have to specify the file? Apparently not. This worked when I tried it 2 seconds ago. Apparently not. API. Oh, it has no messages in there, which is strange. API trace on. Show some. Oh. Oh, I restarted the VPP while I had the client running. Yes, so the stale client died and we disconnected and everything just gave up. Let's try to do things in order. So this client isn't designed to reconnect very well. So show version API trace status. Now we have 10 items in the queue. We do API trace save foo. Then we can do API trace dump foo, and it shows me, so here's the show version call with message ID client index and context that was called, and then the VAT client dumps the whole interface context when it connects. So you can see it first it connects with the main client create call, and then it goes to interface dump to list all the interfaces on the box. So that's very nice to to use for debugging, and you can replay the API messages into VPP as well. So if you get you have a running system, you take the trace, you replay it on your development system, and that's a good way to reproduce bugs and really understand what's going on. Okay, so that's the tracing, the API. Whatever you want to build on the API, you can do. Thought I had. This screen is incredibly small, isn't it? So currently, or up until yesterday, we only supported the root being the client. You had to be a root user to use the client. This morning I saw a commit from Dave where he allowed you to set and configure which user should have access to the shared memory. So now you can run the client not necessarily as root. So if you guys want to try the you guys want to try the Python binding, for example, that is not built by default. So you would do make build. Let me just build that with VPP Lite and VPP API install. Then builds the client code in Python. I'd already done that, so there's nothing to do. You go into VPP API. Let me just pull this one a little bit out. Python, and here you can do Python setup install sudo, and when you've done that, you can run Python, do import VPP API, and you can call VPP API connect, for example. And if you then go to the Emacs window and do show by API client, you will see that this one is connected there, and you can do stuff like VPP show version, gives you that one back. And the Python binding returns you name tuples for all the parameters. So program.decode. Oops. Print sorry, what was I doing here? Program decode. And it prints VP. And if you did build directory, for example, instead, then you get that as a string. As you see, it's encoded as binary. So up until now, at least, I largely use the Python API to do unit testing, configuring, setting up, and combined with Scapy to generate packets. Okay, so you want to run both these sessions before lunch, Pierre? Yeah. So that's until 12:45? Yep. Well, I think we should have time to do some exercises afterwards. Okay, so we're back here. So let's look at some of these actual handlers. So the show version handler. So if you create a new handler, you add it to this beautiful macro here. Just like code layout with the curly braces, don't question it. The underscore macro is used all over the place. It's just accept it as a good thing and go with it, and just follow the flow until you come up with some better idea. But that's how it is defined at the moment. So the show version handler is simply defined as this in the API.c file. So if you put things into the main VPP code, you would typically add your handler in the API.c file, and you would then go and call your action handler, which would typically be in your own directory. But as you see, you just get a pointer to the shared queue. You call this macro to set up the reply structure, and you put these strings. So they turn out to be strings after all, right? But that you would have to go here to verify and see. And the reply macro just looks like this. It allocates a message from the queue, sets the message ID, and returns the context that it got from the client, and sets the value in the retrieval, and sends a message on the in shared memory. So this is the pattern that all these messages follow, and at least to start with, just follow the pattern, and you don't necessarily have to understand all the underlying details to be able to do that. The sample code, so now we're in the MaxSwap sample code, registers its own handler with this message API set handlers function or macro. And let's see. And then it has its own handler defined here, which then just calls the enable disable action handler. So the way this is all tied together is with some clever includes and defines to get the message IDs, because when you do a plugin dynamically, you have to get your own message ID space following the enum, right? So it has to be the consecutive next available number. Let's see if we can. No, what's that called? Yeah, drop that. For the dynamic, for language bindings, currently they do not support plugins. Because at the time of generation, we don't know which API files will be used. Let's see. And what we're thinking about doing, and if you have any good input on that, is to create a dictionary, an API call to get the dictionary, and then you can dynamically assign message ID numbers instead of doing it at build time. So we'll see how that goes. But for the Python binding, right, we just use the main VP.API file, passes that to the VPP API gen, which then outputs the Python devs. But again, purely from a user perspective, this is all the stuff you have to do for the API. You have to, include the API files at the top, and you have to ensure you get, follow this pattern here to. So this is the signature of the API to ensure that the client and the server matches. Then you define these macros. So you add each of your message types here, and you provide a sample.api file for the message itself. And if you do this within VPP, you typically add it to the main VP.api file. If you do it as a plugin, you add it separately here. And yes, probably you'll end up using Honeycomb, right? Or something higher up than this. But anytime you add functionality, you have to start here, right? And then it will trickle out. And I think you would have to start here, do that, define a Yang model, and then it will implement it in Honeycomb, and then you can write your applications on top of that. I think there was in the old days there was some support for netconf directly from VPP, but that's been taken out and disabled, I think. But I see some remnants in the VPP API file. No, luckily it's taken out. So, any more questions on the API? Do you want to try a small exercise of adding a call to the sample plugin? Just add a is it enabled or disabled command, for example, or show status, for example, a show message, both in the CLI and in the API. And spend 15 minutes on that and try to see if we can do it. Okay, good. So let's give that a go. So we have until let's do 15 minutes on that. Just do the CLI and the API, and I'll nominate one of you to come up and present your solution when you're done. So there will be no pressure. It's just to give you a taste of how it would look like, and it's it is relatively simple. Typically, just following the templates that are there, but of course, it requires holding your tongue correctly in your mouth, presumably your own mouth. Did anyone manage to get the CLI added? Yeah, cool. We have a winner. Brilliant. What was the biggest, was there any issues that you ran into that you want to discuss, or was it just straightforward?
So I duplicated the enable disable command.
Yeah.
The difficulty was probably many things are defined in macros. It's hard to find where.
Yeah.
And I had some difficulties also to find the sample.api file. So I grabbed in .cn.h and I said, where is it defined?
Yeah.
And it's the API file.
Yeah.
So
yeah. There is a lot to get used to, right? And when you get used to it, you just take it for granted and you don't think about it anymore. But it's certainly a steep learning curve. But if you implement your first function, spend a week or two on that, I mean, it will. There's a lot of sighing here. I think David Brack says that it will take a person, someone with the right personality and grasp of things, 3 months to get fully up to speed to be a, someone who can really do valuable contributions to VPP. But I think that's not necessarily true. I mean, that's true if you really, really want to write code that goes very, very fast, understand the cache hierarchy, do really, really clever stuff. What I found is I just wanted a simple tunnel concentrator. I'll show you the code tomorrow. Take a V4 packet, encap it in V6. Take a V6 packet, decap it, and forward V4. And you really don't have to understand, the deep things. You just follow the patterns and doing lots of quite cool things with VPP is very, very simple without requiring you 3 months of hard studying. But he likes to say that, but he's an absolute genius. I have massive performance anxiety asking him questions because he's very, very helpful if you ask him the right questions, and but he has relatively low patience for for not the right questions, and I guess all of us are a bit like that. But as I said, if you start off following, doing the skeletons, following those, doing the templates, things are quite simple, and you don't have to understand, every single detail. But at the same time, it's very, very flexible, and you can do almost what you want. Okay, so let's finish with the API for now, and look at the max swap node. Any more questions on the API before we make the jump? So when you register a node, as Pierre also showed, here's the max swap node. You register with the VLib register node macro, specify which function to be called, the name of the node, which has to be globally unique. And then you define, your trace function, type of node, as Pierre said, for the packet processing nodes, sitting in the middle of the graph here, there would be VLib node type internal. Your set of error strings, which you will show in, show errors, and a set of next nodes you have, which is, a vector of next nodes. And in this case, it can only go to interface output. Probably a better. Let me just see if I can show you another one. Yeah. So, for example, for my tunnel encap node, it's a bit more realistic, I guess. So the set of next nodes here So I take a v4 packet, I encap it in v6 and send it to IP6 lookup. So that's the base path there. I have a shortcut way of doing it. So bypassing the v6 lookup and say that I pre-calculated the rewrite strings, I send it directly to IP6 rewrite node. Or if I'm unlucky, I have to do inner fragmentation. So then I send it to the IPv4 frag node, or I do outer fragmentation of that v6 packet and send it to the IPv6 frag node. Or God forbid, I have to reassemble it, or I have to generate an ICMP error, or I send it to error drop. So when I get a full vector packets in, those are all the possible output nodes that particular node has. And I think someone wrote a little tool to just generate dot files, so you can get the nice graphical representation of the whole directed graph of nodes. So this is you register the node this way. Then the interesting bit that we talked about a little bit before is how do you actually sample, let's see. How do you actually register that node with your parent? So either you do it statically, or you can in this max swap case, it's that hardware RX thing, right? The node here supports this this API to add add arbitrary nodes to take over traffic. So for a particular interface, you now set the next index for that node to point to you. That's not terribly flexible, but it's useful in some cases. But now you take the you get the packet very, very early up in the graph. Let's see, in the IP4 map node, we do it quite differently. So our parent is IP4 lookup, and IP4 lookup does a fib table lookup, gets an adjacency index back. In the adjacency, there is a lookup next index. And since my tunnel owns a fib entry, so I have a root in the table, and I associate that with an adjacency that has the lookup next index being the index of my node. So it's essentially you have to have some sort of contract with your parent node of how you want to get packets. And typically the classifier, for example, you would register your node with a classifier for certain types of traffic is one way of getting traffic as well. Different ether type, for example, would get you traffic. Okay, so node. Oops. It's a terrible idea calling things node.c. Don't do that. So here's the main packet processing function, and there's an Emacs skeleton for this. Does anyone understand this and want to come up and explain it? Yet? You've seen it a few times. It gets called with a from. I actually have a slide. But what happens is essentially that you present it with a source frame, the from. So in it, you get a pointer to the source frame. You get the number of packets in the from vector in the frame, and in the node you stored the cached next index. So we have this prediction that tomorrow is very, very likely to look like today. That applies to almost everything. It applies to relationships and the weather, and but we assume that the next packet is very much likely to behave the same way and be treated the same way as the current packet. So cache the next index, so that's the destination frame. And we spin through these two while loops. So while there's packets left in the frame, we get the next frame, the destination frame, with a pointer to next. So where's the first free slot, and the number of free slots in the vector up here, right? Then the other inner while loop, we spin through that as long as there's packets left in the source frame, so here, and we have slots free in the destination vector, we get the buffer index, so that's packet 0. We write that buffer index into the free slot in the destination frame, and we move these pointers around, right? We move this pointer up to packet number 1, we move this free slot to next one up here, and we decrement the number of packets left. And this pattern you'll see everywhere. All the processing, packet processing nodes do this. And then we do real cool things with packets. And there's a certain way of writing these cool things with packets, because we have, so you'll see later, this is the deal with one packet at a time loop. We have another loop ahead of that which does 2 packets at a time and interleaves the instructions. And then when we're done with that, we call vliv validate buffer enqueue x1 in the single loop, x2 in the dual loop, that verifies that we actually got it right, that our guess of destination frame was right. And if it isn't, we dequeue it from the wrong frame and put it in the right frame. And we set a cache, the cache next index to whatever we picked last. And then at the end of this, we commit the frame and add it to the pending frames vector. And that's what the scheduler will then go through and schedule those nodes for processing.
Okay. The assumption here is that everything happens on a single core, right? That this is not multi-threaded.
Right.
So what happens in the situation that there's a kind of dispatcher that needs to send frames to different cores?
So in the typical model we have with, let's say you had 32 worker threads, then, those threads would run those, this processing, this node would run on all of them, right, in parallel, independently. And dispatch, dispatch would be done by, RSS, for example.
RSS, yeah, the hardware RSS. But yesterday we were also discussing the kind of the software RSS.
Right, with the I/O threads,
that uses a different scheme somehow.
Yes.
Different types of.
Yes, all these data structures are per core. So, Damian, do you want to say anything more about the? Don't shake your head. That's it, he says. But certainly the model that I worked mostly with, and it depends, right? But it's worker threads and use RSS, and we got much lower performance trying to do it with I/O thread than I would with RSS and multiple worker threads, or scale up number of interfaces. But that's largely because the node I'm using in my use case is it does not do very much processing, right? It's not like it needs a massive pipeline where you have to spend hundreds of cycles doing anything. Let's see. So this was so the loop we looked at. So this is a single loop, right? So it does what? So this is the inner loop. It does, as long as I have packets left and there's space in the destination frame, I go down here. I set my next pointer, my next index to be sample next interface output. So it just dumps it straight to the interface. Then I do, move those buffer indexes around. I get a pointer to the actual buffer from the buffer index. We assert that. Okay, I wonder when that would not happen. We assume that the Ethernet header is at the current place in the buffer for current data. So we move that. So get current just is an accessor for current data. And if you do tunnel encap, you move that around, or you want to put something in front of the packet, you just move that pointer. If you want to put 40 bytes of E6 header there, you move it 40 bytes forward. Yes, please.
Packet data, the buffer for the packet data, you assume that you can access that randomly, random access to every byte in the packet data.
you know, if you keep yourself within the first cache line of the packet, the world is happier. If you spend 2 cache lines, the world is probably still happy. If for every packet you look at, you know, the end to see if there was anything cool at the end, or, you know, pass through the whole thing, you're less happy. And it's certainly a discussion we have in the IETF about, you know, IPv6 extension headers, which is essentially this linked list of headers you have to parse to get to the layer 4 information. And that's not very, sure, it's a software forwarding platform. We can do whatever you like. It's, you know, it's just a matter of code, but it is certainly not a friendly way of doing it, even in software, right? Because we will have to pull in new cache lines. Very hard to do prediction as well, or you know, preload the cache for the next packet, because you have to follow chase, essentially chase pointers around to get to your layer 4 information. It's certainly doable, and it depends on how fast you want to go, right? But, you know, if you want to make the highest performing packet forwarder on the planet, I mean, on a 100 gig link with small packets, I think you have about 6 nanoseconds per packet. How much do you want to do with the packet? But yes, you can access the whole buffer.
I can see any prefetch.
Here, there is no prefetch. If we go up to, there should be some up here. Should we quickly do the single loop first, and then we go up and look at the double loop afterwards? So this is the code which is called, you know, if you have 13 packets, you will only get the 13th packet coming down here, right? The odd number. So get the Ethernet header. We do, you know, enjoyable preprocessor magic macros here to swap them around. So this, and apparently it's not the fastest way to do this. So I think we'll leave that as an exercise to the audience to figure out a better way of doing it. And just gets the software IF index from the RX interface, sets the TX to be the same, so it just loops the packets around. You know, just sets, here's the output IF index, and here's the trace. Here's the necessarily trace code you have. So Pierre talked about those flags. So if the vlib node flag trace is set, and that's set with the trace add command, then you add the trace, you know, with the function that you provided in the registry. And it's, you know, very, very useful for debugging as well. So it's useful to do that and support that and add tracing functionality. Then we increase a counter and do validate that we got to the right place. And we do increment a counter at the bottom here for packet swap. So if you do the show error, they will show up that this node forwarded packets, or at least flip them around. So that's the loop that handled 1 packet. So here's the loop that handles 2 packets at a time. And as you see, the convention here is just to have a variable name with 0 and 1 concatenated or postfixed. So 0 for the first packet, 1 for the second packet. And you have to duplicate all of these variables. And we also do a prefetch on packets number 3 and 4. Or 2 or 3. Why don't we just accept that we should count from 0 also in daily life? It's kind of hard, isn't it? But this is essentially, you know, prefetching packets number 3 and 4 while we're processing packets 1 and 2. So we're ready. Those are, you know, we heat up the caches, get those into cache before we get to them. And of course, you know, anytime you process a packet and you deal with parts of the packet that is not in cache here. If you wanted to look at offset 1300 in the packet, you will get stalls, right? Because that's not typically wouldn't be in cache. It depends, right? It's really hard to say. I mean, if you get DMA straight into L3 cache, then sure, you might have the whole packet there, and there might be no overhead, right? So it depends. So we do the prefetching here. Do the same moving about in the from and the destination frames. Now we change the pointers with 2 instead of 1. Get both buffers, pointers to the Ethernet header, and swap both of them, and set the software IF indexes for both of them. So it's essentially the same as a single one, just that we do it interleaved, packet 1 and 2. What you have to think about here is, if you encounter an error with one of these packets, you can't just bail out, right? You have to, you really have to, run through the whole loop, because packet number 2 might be all right, and you want to pass that on. So they might split ways here, right? One might go to the error node, one might go to the interface output. But you can't just do go to error here, or jump out. So you have to deal with, for example, you might have some sort of session table going. Right. So for the coding pattern here again, if you have a session table, for example, you do a lookup to get session identifier for packet 1 and session identifier for packet 2. You really can't. And if you don't find a session for packet number 2, you can't bail out, right? So typically what we do in data structure is just to have a dummy entry, for packets you didn't find. For the adjacency table, adjacency index number 0 is just, that's the miss. You didn't hit anything, but you still have a valid, valid index that you can use to allow these packets to flow through the normal data path, even though they're errors. So typically what we do is write a simple single loop first, test that and make sure that works, and then do the manual labor of expanding it into the dual loop. But it's important to think about that when you write the single loop, that it allows for that. You don't sort of bail out, or do a continue or something in the middle of it, because that won't work in the dual loop. And it is a bit of consideration of what you're doing and how often you're called. Are you in the main path? Certainly, for ICMP error handling, I don't bother with the dual loop. I just do the single loop, because it's a corner case. You don't have to optimize how fast we can send ICMP messages. Same thing for neighbor discovery and ARP messages and stuff, for example.
So that's probably where it happens. You see something that doesn't look like an usual loop. You have put next frame and get next frame. These are actually the macros that you call when you need to change your frame. So I guess here I have a bunch of fragments that I want to send, and I know I have n left in my output vector frame. So I do the same principle, validate enqueue as much as possible, and when I have either no fragment left or I have no more vectors, space available in my output frame, I do put next frame to just say I don't use this frame anymore, and I do get next frame.
Where do you actually split the buffer, or where do you get?
Where do you split?
Fragment, perhaps.
Yeah, I guess. Yeah.
Yeah, that returns a vector of buffers, right?
Do you know the shortcut to go there?
Yeah.
So while I still have some bytes, I guess.
You call vlib buffer alloc, which returns a buffer index.
Yes, that's it. This is to get more buffers. You can get allocated buffers. as you need.
DPDK has a kind of a meta buffer. Do you remember what they call that for fragmentation, where you just carry, you know, the header, and then you keep a pointer. So you have you keep your single buffer, and you have, you know, these meta buffers that point into various places in the content. So, you know, at the output, TX output, you actually you know, create the fragments out of a single buffer instead of you know, now you copy actual data around, don't you? Yeah.
We could probably do something similar with the clone counter, but yeah, in this case, in the fragmentation code, the data is copied, or at least as it's copied when it's necessary. If I have like jumbo frames, or actually no, it's not upstreamed, but I wrote some code which was dealing with jumbo frames, and then I would try to make sure that when I can reuse the buffer, then I reuse it, and I do only memory copies when necessary, because memory copies are very expensive. But with I think the clone counter mechanism, we could try to make something more clever, where we, as we discussed earlier, we generate an IP header for each fragment, and then we chain a buffer which includes the content. But that's fairly dangerous to end up with packets that are that have a very small header, because you don't know, maybe there is a node that does something somewhere that doesn't deal very well with chain buffers. So usually, I mean, you need your header to be in the first buffer, that's for sure, including the extension headers and so on. And then you can put the data in other buffers at your own risk, I guess.
So we have, you know, we have a use case where, you know, for these tunneling cases where often you have to support the inner payload of 1500 bytes, and, you know, the resulting packet encapsulated would be 1540, and that shouldn't, you know, result in chain buffers, but it's probably easier to just increase the buffer size than for all buffers up to whatever size you have to support. You know, if that was 2K, make 2K buffers instead of having to deal with chain buffers for that case, you know, for jumbograms. A colleague of mine in the IETF has a draft called draft Bonica deprecate fragments, I think, IP fragmentation or something. I'm certainly in favor of that, but it has some consequences for a few apps. But yeah, if you have to do fragmentation is easy, reassembly is hard, right? So if you end up with any of these tunnel schemes that depend on fragmentation, you're in trouble. So for this tunnel concentrator, we do support fragmentation, but if you actually were to use it, it would, you know, work well for us. I mean, we don't care about fragmentation, but, you know, or generating fragments and sending them out. But, you know, the poor users on the other end who would, you know, a large part of the internet drop the second fragment, for example, or they would have to, you know, reassemble it. Yeah, fragmentation is just a DOS attack. Just stop doing it at layer 3. It's a transport problem. But I think everyone, you know, most people in the industry do agree with me. It's just that, you know, it's no way out of the rut we're in. I mean, you know, DNSSEC, for example, and the DNS guys being, you know, the UDP application that is perhaps most hard to change. They're very, very keen on having stateless DNS servers. They, you know, they don't want to go through a TCP handshake. And with DNSSEC, UDP packets become quite large. And, you know, that's why DNS servers are, you know, main source of DOS amplification attacks as well, because it's trivial to send a query to a DNS server, get a, you know, very big packet, IP fragmented back. So you send a tiny query, you know, 60 bytes or so, and you get 4K back. But they insist that it's not a DOS attack. It's not DNS's problem, and IP fragmentation is the only way they have to deal with DNSSEC. So I could show you, you know, just quickly the how a tunnel encap would look like. I think Damien is probably going to look further into that. But this is an actual actual v4 to v6 code. Just gets the buffer, gets the IPv4 pointer to the IPv4 header, because I can do that because I know I come from IPv4 lookup. I do a lookup in a session table to get session information pertaining to this particular IPv4 address. Get TCP or UDP port, play with the TTL, don't fragment bits, then calculate the resulting v6 addresses I want to use. Here I just move the pointer size of the v6 header forward in the buffer, and then just write the IPv6 header directly into that buffer space.
Check afterwards if there was space. No.
Well, so I know the the v6 header is 40 bytes. It's not going to expand anytime soon, even though we're we're respinning RFC 2460 to Internet Standard. We're not changing the header size, the encap string buffer was 128 bytes, right? So I just overwrite the Ethernet header here, right? So 14 bytes. So I added 26 bytes to the packet. Go through and set which destination frame am I going to send this to. If we fail on the MTU, we fragment the inner packet. In this case, by default, if you have an error, we set it to drop, which goes to the error drop nodes, which largely just counts and drops the frees the frame and the trace stuff, and the same thing. Validate that we got it to the right place. So this is all that's needed to take a v4 packet, get the port information, and calculate destination addresses based on what was in the port and v4 destination addresses. So it's this is easy, right? I mean, you can't get it very much simpler than this, which is why I thought coding in VPP is so much fun. Possibly because my life previously have been so miserable, but we could allow for the possibility that this is actually a nice framework to deal with packets. There's nothing between you and the packet, which I certainly like. Here's the header, just dump it straight into the buffer and send it out. And there's no one staying between you and the wire in reality, which is nice.
Are you also going to show how you hook it into the L4 IPv4 lookup adjacency thing?
Yes, let's do that. So this is where the way that this tunnel mechanism hooks into the structure is by adding a route to the fib table and setting adjacency, and it does that here. So it creates an adjacency and sets the lookup next index to be either IP lookup next map T or IP lookup next map. So the one is encap and one is translation. So whenever IP lookup hits that particular route, gets that adjacency, it will then give me the packet next. So that's one way of interfacing with your parent node. And it would, as I said, it would depend on what kind of parent you have and how you would interface this way. But this is a very sort of non-intrusive way of doing it, right? Because I don't have to change any code in the IP lookup at all. I just add a route in the fib, and I get the packet. So quite different from how some other people implement tunnel or other tunneling mechanisms where you have an interface. For example, we don't have an interface. We have it's a session table combined with using the IP and the IP4 and IP6 fibs to get the packet. But your mileage varies with the mechanism, right?